Assalamualaikum. My name is Muhammad Izzat Ikhwan bin Zulkifli. My metric number J19A0193. I will present about introduction. Proposed membrane have been produced from a variety of polymer using a number of techniques, including space inversion, electropinning, sintering, mill spinning, and cold stitching, 3D printing, and other. PVA is a polymer that combines the aforementioned characteristics with outstanding film forming abilities, chemical and mechanical stability, and adjustable hydrophilicity. Biological organisms may quickly degrade PVA, which is essentially created from polyvalently acetated by hydrolysis, and is solubilized crystalline structure polymer in water. Swadus derived CNC were successfully integrated into a polymer-based thin film composite membrane. The CMC polymer could significantly improve the mechanical strength of the measured membrane due to the abundant hydrogen bond among and between the CMC skeleton. Okay, next I will continue with problem statement. For survival, you need water. Unfortunately, it is become more and more scarce global. There is a significant demand for the scarce fresh water supply as a result of the change in water usage habit. Rapid population growth has raised the demand for high quality drinking water and other type of water. For contaminated water supplies, membrane technology has been shown to be a good pollution remove technique. The most frequent regulating factor for strength in membrane processes is the pressure gradient. Next is objective to create a technology that might successfully assure long-term use and water safety. To prepare water valorization, including the recovery of valuable dissolved component and heavy metal.
Hello, my name is Arana Azami Jazmi and my matrix number J19A0091. And the next part is the materials. The list of the material that we use in this experiment, which is polyvinyl alcohol 5 weight % PVA, cellulose nanocrystal 5 weight % CNC, carbomethyl cellulose CMC, distilled water, beaker, measuring cylinder, glass rod, hot plate and thermometer, and a petri dishes. The characterization instrument that we use to examine the sample, which is the optical microscope, scanning electron microscope, sensor test machine, Fourier infrared spectroscopy. And then for the methods, first of all, to make a sample, we must have a 3 solution, which is CNC solution. First, measure the 5 gram of a CNC and with 100 ml of a dionysus water with constant stirring at a 45 degrees C to obtain the 5 weight % CNC solution. Next, for the PVA solution, we measure the 5 gram of a PVA in a powder mixed with the 100 ml of a distilled water at a 90 degrees C with a constant stirring until completely dissolved to obtain the 5 weight % PVA solution. And then, for the CMC solutions, we have a 3 gram of a CMC dissolved with a 25 ml of the distilled water and keep stirring. First, to make a sample, we must measure 10 ml of a PVA solution and add 2 ml of a CMC. Mix the PVA solution with the CMC solution and continue stirring on heat the mixture on a hot plate at a temperature 90 degrees C until it fully homogeneous. After the mixture completely homogeneous, pour the mixture into 2 different petri dishes and let the solvent dry for 48 hours to ensure slow evaporation of the solvent. And then prepare the next sample, which is measure 10 ml of a PVA solution and add a CMC solution and continue stirring until it completely homogeneous. Then add 5 ml of a CNC in the mixture and keep stirring for 30 minutes at 90 degrees C. After the mixture completely homogeneous, pour the mixture into 2 different petri dishes and let the solvent dry for 48 hours for ensure slow evaporation of the solvent. After 48 hours drying, resultant film should be peeled off the dish gently and store carefully for further characterization. For the result and discussion for characterization using the optical microscope, the magnitude used for OM test it is 5 and 10 magnification specification. For the sample PVA and CMC, 5 and 10 magnification surface in the smooth surface and having a air bubble. For the sample PVA, CMC and CNC, 5 magnification roughly surface because of the bubble. And then for the PVA, CMC and CNC sample, 10 magnification, we have a tiny bubble occur in the surface. That's all from me.
The next test is the SEM test. The SEM test is used to testing the sample 2 and the sample 4. The sample 2 is PVA plus CMC blend films. The sample 4 is PVA plus CMC plus CNC blend films. The magnitude used for SEM test is S30, S100, S200 and S300. The PVA plus CMC blend film showing a smooth surface morphological different than PVA plus CMC plus CNC blend film showing a higher roughness surface morphological. The observation showing that the PVA and CNC are incompatibility as two different constituents. For the smooth surface morphological film has a better compatibility than the higher roughness blend films.
Hello, my name is Saw Ziwei and my number matrix is J19A0298. So today I will be discussing the FTIR analysis for my group's sample. So FTIR analysis usually analyze the functional groups that are present in the sample. So for our sample at around 3000 to 3400, we can see that there are presence of OH stretch. After that, at 2850 to 3100, there are presence of alkyl CH stretch. There are no indication of triple bond in this sample, and to conclude my part, our sample have at least one OH bond or possibly more, and there are no presence of double or triple bond. Thank you.
For the result and discussion for tensile testing, PVA plus CMC, the Young modulus is 1.26 Nm², stress at peak is 0.657 Nm², and the stress break is negative 0.071 Nm². For the next sample is PVA plus CMC and plus CNC. The Young modulus is 5.21 Nm², and the stress at peak is 0.45 Nm², where the stress break is negative 0.01 Nm². Lastly, for the conclusion, the development of PVA-based porous membrane will continue as long as functional nanomaterial are used and new approaches to controlling the pore structure, such as microfluidics, discovered. PVA is currently one of the polymers of preference when it comes to direction by preparation. by successfully incorporating cellulose nanocrystal CNC made from sweat dust and using the interfacial polymerization approach, polyamide membrane was changed. The straightforward synthesis method that uses gas carrier CMC as an adhesive metric and capping agent to create a mouth-based membrane might be used to a variety of systems. That's all for our group. Thank you.